This week's physical science tutorial is going to be on the gas laws. There are 3 gas laws that we're going to talk about in this tutorial. The first one is Boyle's law. Which says P1 V1 equal P2 V2. Capital P stands for pressure. V stands for volume. And the P and the V on this side also stand for pressure and volume. Now, it doesn't matter what unit your pressure and volume is in as long as they're in the same on both sides of the equal sign. For example, if volume is in milliliters on this side, then it would also have to be in milliliters over here. If not, you're going to have to convert one or the other. So let's do a couple of example problems. What is the pressure of, that's a P, a system that starts out at a pressure of 5 atm and a volume of 50 milliliters and ends at a volume of 25 milliliters. So the hardest part about this is deciding what goes with what numbers go together. So you're going to write your formula just like we did with density. So P1 V1 equals P2 V2. And then we have to decide which ones go together. So the numbers that we have here are 5, 50, and 25. So 50 and 25 are both volumes. So we know one is V1 and one is V2. But which one does the 5 go with? Does it go with the 50 or the 25? So we have to read carefully. It says at a pressure of 5 atm and a volume of 50. So the 5 and the 50 go together. So I'm going to go ahead and assign them as P1 and P2, which would make this V2. So we are going to be solving for P2. Alright, so let's plug in our numbers. P1 is 5, V1 is 50. I should have said V2. What did I do? I should say V1, sorry. V1 is 50. P2 we don't know. And V2 is 25. So in order to get P2 by itself, we're going to be dividing by 25 on both sides. So in my calculator, I'm going to type 5 times 50 divided by 25. And that gives me 10. 10 what? We have to look at the measurements for P1. Since P1 was in ATMs, then P2 must also be in ATM. Let's do one more of these, but let's do one that has a conversion in it. A balloon has a pressure of 15 atm and a volume of 1.5 milliliters. The volume is decreased to 0.0005 liters. What is the new pressure? So again, we're going to write our formula. P1 V1 equals P2 V2. Then we're going to decide, we're going to underline all of our numbers. and then we're going to decide what goes with what. I know that the 15 and the 1.5 go together. So this is a pressure, and this is a volume, and I'm just going to call them 1 since they were mentioned first. So that means that this would have to be volume 2, and we don't know, again, what P2 is. But if you look at your volume measurements, one's in milliliters and one's in liters. So you have to convert one or the other. It doesn't matter which one you convert, you'll still wind up with the same answer. So I'm going to go ahead and take 1.5 milliliters and convert it to liters. There's 1,000 milliliters in a liter. So basically I'm taking 1.5 divided by 1,000, which would be 0.0015 liters. So now for P1, I have 15. For V1, I have this new number here, 0.0015. We don't know P2, and V2 is 0.0005. So to get P2 by itself, I'm going to divide by 0.0005 on both sides. So let me go do that in my calculator. And I got 4.5 for P2, and that's going to be in ATMs because P1 was in ATMs. So that's my answer. So that's the first gas law. The second gas law is Charles's law. So this is number 2. And Charles's law says that V1 over T1 equals V2 over T2. And for these, temperature has to be in kelvins. And we'll talk about how to convert from Celsius to kelvins in class, but for now I'll just go ahead and give you all of the conversions in Kelvin, or all of the numbers in kelvins. Remember, volume doesn't have to be in anything specific as long as it is the same on both sides. So T is temperature and V is volume. And temperature has to be in kelvins. That's the only thing that has to be in a specific unit for these laws. So let's do a couple of these. What is the volume of an object with a temperature of 303 Kelvin if it started out at 273 Kelvin and 3 liters. So we're going to write our formula first. Then we're going to go underline our numbers. This is a temperature, this is a temperature, this is a volume. This volume goes with this temperature, so we're going to call this T2 and this V2. You could have called it T1 and V1, that would have been fine. You would have still wound up the same answer. So that would make this, since this is T2, this would be T1. So we don't know V1. So we're going to do V1 over 303 equals 3 over 273. And then we're going to cross multiply this. So 273 times V1 is 273 V1. 3 times 303 is, let me go to my calculator, 909. And then to get V1 by itself, you divide by 273 on both sides. So again, let me go to my calculator. And the answer is 3.33. And since this is volume, it's going to be in the same units as the other volume, which is liters. So 3.33 liters is your answer. Now you can always go back and plug this answer in here and see if you actually do get equal numbers on both sides if you have time. It's nice to do these because you can always check yourself. Alright, now we're going to do the last kind of law, which is Gay-Lussac's law. And this one is pressure and temperature, and it's P1 over T1 equals P2 over T2. Where P is pressure and T again is temperature, and temperature has to be in kelvins. So if it's not, you have to convert, which we'll talk about in class. For now, I'm just going to give them to you all in kelvins. So let's do an example problem, and I'm going to throw a conversion at you in this one. A system has a pressure of 248 kPa, which are kilopascals, and a temperature of 298 K. The pressure changes to 25 pascals. What is the new temperature? So again, you use the formula, write it down first, and then you go underline all of your numbers and decide what variable they are and if they go together. So kPa is a pressure, kelvins is the temperature, and Pa is another pressure. This temperature goes with this pressure, so we're going to call this P1 and T1, which is going to make this P2. But notice that your pressure readings do not match up. You have kPa and Pa. So you have to convert one or the other. It doesn't matter. I'm going to convert the 25 to kPa. So I'm going to go from Pa to kPa. Kilo means 1,000. There are 1,000 bases in 1. So 25 divided by 1,000 is 0.025 kPa. So now I can go plug in my numbers. So P1 is 248 divided by T1, which is 298, equals P2, which is 0.025, and we don't know T2. So I'm going to cross multiply these, and I'm going to erase some up here so I have room to do this. Ignore all my little dots there. So 248 times T is 248T, and then 298 times 0.025, I'm going to go do that on my calculator, is 7.45. To get T by itself, you divide by 248 on both sides. So again, I'm going to go do that on my calculator, and that gives me T equals 0.03 and temperature is in kelvins. So that would be my answer for that one. Alright, don't forget to go and take the quiz on this video. It will be posted until Sunday night. Good luck.